Welcome to The Explainer. Today, we're diving into a concept that solves one of the oldest, literally most universal headaches in the entire history of software development. I'm talking about the absolute chaos of handling nothingness in our code. If you've ever written an application and watched it just completely crash and burn because a variable was unexpectedly empty, yeah, you know exactly what I'm talking about. We're going to explore a brilliant architectural design called the Null Object Pattern. It completely flips our understanding of missing data and shows us how to take nothing and make it do, well, something.
Okay, let's dive into this by looking at where this problem actually started. The concept of null, or nil, representing the absence of a value, was invented back in 1965 by the highly respected computer scientist Tony Hoare, and he famously issued an apology for it later, calling it his billion-dollar mistake. No joke. He introduced it simply because it was so easy to implement at the time. But over the decades, the null reference has caused just innumerable bugs, system crashes, and endless frustration for us. In many ways, null has become this historical villain in object-oriented software design.
So here is our roadmap for today. We'll start with the problem with nothingness, see how polymorphism comes to the rescue, and then enter the null object pattern itself. After that, we'll jump into some practical examples covering game-moving behaviors, iterators, and commands. Finally, we'll wrap up by asking, is nothing actually something?
All right, let's kick things off with Section 1, the problem with nothingness.
So, the core issue with nothingness, it's branching. When you have a definite variable, like one that's absolutely guaranteed to be an integer, your code has one predictable path. Easy, right? But the second you introduce a nullable variable, meaning it might be a string or it might be absolutely nothing, you force the program to split into two separate paths. You suddenly have to write this messy if-else conditional just to check if the value is null before you can even do anything with it. And we all know what happens if you skip that check and the program tries to read a null value. The whole application blows up. Basically, every nullable variable breeds a plague of defensive if statements.
Which brings us to Section 2, polymorphism to the rescue. Now, polymorphism is arguably the absolute superpower of object-oriented programming. At its core, it lets us treat objects of completely different concrete types as a single general parent type. Because they share this parent type, you can dispatch method calls to them uniformly. You trust that each specific object is going to know exactly how to handle the instruction on its own. You don't actually need to know exactly what the object is, you just need to know what it can do.
Think about the classic animal interface. We define a rule that any animal must have a speak method. A cat implements this and meows, while a dog implements it and barks. Because of polymorphism, a general function can just accept any animal and tell it to speak. No messy conditionals checking the exact species. The objects manage their own behavior. You just send the message and they do the rest.
Moving right along to Section 3, enter the null object.
So we have our cat and our dog implementing the animal interface. But what if there is a scenario where absolutely no animal is present? Instead of returning a dangerous null that's going to crash the application unless we write an if-else check, we create a brand new class. Let's call it noAnimal. This noAnimal class implements the exact same animal interface, but its speak method does absolutely nothing. Think about that for a second. We have effectively rehabilitated nothingness. It's no longer this unpredictable void. It's a polite object that perfectly mimics an animal, but simply stays silent when spoken to.
The fundamental rule here is super simple. Replace conditionals with polymorphism. The null object pattern is basically just a really great reminder of this rule. Whenever you see a null check in your code, checking if something is empty before acting on it, there is a very high likelihood that you can swap out that null for a null object and just let polymorphism handle the rest. It cleans up the code, removes that annoying branching, and makes the whole system vastly more stable.
Let's see this in action in Section 4. Example, game-moving behaviors.
Imagine you're building a fast-paced side-scrolling video game. Your player has a normal moving behavior. When you press the right arrow key, it moves the character's coordinates to the right. Makes sense. But let's say the player hits a bad power-up and becomes frozen. Traditionally, you might add a big if not frozen check to every single keystroke. Instead, using our new pattern, you simply swap the player's behavior to a no moving behavior. So when the player frantically mashes the arrow keys, the game system still confidently sends the move right command. It doesn't crash, and it doesn't even need to check the player's frozen status. The no moving behavior receives the command and simply doesn't do anything. It's seamless, it's elegant, and best of all, It's bug-free.
Let's move to and see how this builds in Section 5. Example, iterators and commands.
Take a standard tree hierarchy. You have a root node, composite nodes that contain children, and leaf nodes at the very bottom that don't. When traversing this tree, instead of writing conditionals, checking, if you are a composite, give me an iterator. If you are a leaf, do nothing, we just use polymorphism. The composite nodes return a normal iterator. The leaf nodes simply return a null iterator. And that null iterator acts exactly like a real one, but it just replies false whenever asked if it has a next element. Boom! No application errors, no if statements. And we can apply this exact same logic to user interfaces using the command pattern. Imagine a dialog box where the OK button is loaded with an accept command to execute a data save. But what if, on a specific screen, you want the cancel button to be completely disabled? Instead of writing complex conditionals to check if the button is active before firing an event, you simply load the cancel button with a no command. When the user clicks it, it securely, safely executes nothing. This no command trick becomes incredibly powerful for features like an undo history in an app like Photoshop. Say a user applies a blur filter, then applies a sharpen filter. The next step might be a placeholder or an empty state loaded with a no command. Because a legitimate object is sitting there rather than a dangerous null void, you can safely traverse this history backwards. Every command, even the no command, knows exactly how to unexecute itself. The system gracefully moves backwards without ever crashing on an empty step. It's like magic.
Finally, we arrive at Section 6. Is nothing actually something?
There is a wonderful, highly recommended talk by the brilliant software engineer Sandy Metz titled Nothing is Something, and it hits the nail on the head. The null object pattern forces us to realize that an absence of behavior is in fact a behavior in itself. Doing nothing is a completely valid action. By elevating nothingness into an actual object that our systems can talk to, we remove the fear, the crashes, and all that chaotic branching logic that Hoare's billion-dollar mistake introduced decades ago.
So, I want to leave you with this provocative question to really chew on. Is it possible to replace every conditional with polymorphism and every instance of a null with a null object? Now, while replacing absolutely everything might be an architectural extreme, challenging yourself to rethink every null you encounter in your code will radically transform the way you design software. Every time you find yourself writing a defensive, if not null statement, ask yourself, could an object beautifully do nothing for me right here? Thank you so much for joining me on this explainer. Keep asking great questions, and I'll catch you.